We just had some understanding of solutions of Dirac equation. So in which we not only took the positive energy solutions but also the negative energy solutions in that sense. And at the end, we also tried to see how we could see the Lorentz invariance or covariance of Dirac equation in two reference frames vis-a-vis these four, what I should say, solutions, which included not only positive energy solutions as well as negative energy solutions. So this was our yesterday's thing. In today's thing, we are going to see, so we can extend the same to the way we extended this covariance to energies at different energies also. We can extend उसका हम generalization भी कर सकते हैं. Check the book has given a bit. We'll skip it. So today's thing we are going to see how something called projection operators for energy and spin. So projection operators, the in quantum mechanics, if you remember once we studied advanced quantum mechanics, we had operators, projection operators. So here also we have to have projection operators vis-a-vis energy and spin. In spin we had polarization, polarization करते थे. Polarization, for example, whichever polarization, which correspond to the different states, up states or down states. जैसे हम spin up और spin down करते थे. For a given sign of energy and polarization, so these polarizations for a given energy and spin is 4 dimensional analogs for non-relativistic two-component operators can be P plus minus is given by projection operators along this, where sigma z can be any of the spin, sigma x, sigma y, sigma z, and sigma 0. They will be different spin polymatrices. Which will be having spin up and spin down amplitudes. So for a Dirac equation, so we are going to search for our 4 operators. So we find for 4 operators. These operators, 4 operators, which are going to project the plane wave solutions. Plane wave solutions of momenta or project plane wave solutions of momentum P, and they will correspond to positive energy solutions and negative energy solutions. So we'll say अब जो भी projection operators हैं, which are basically plane wave solutions of momenta, we'll also want that they should have a covariance properties, है ना? Covariance they should have, or they should satisfy covariance they should transform as covariant forms in the various Lorentz systems. You can see that covariant for various Lorentz systems. So for projection operators, which can be denoted as propagation operators can be denoted like this. So it can be denoted like this. After coming back, yesterday, if you remember, we had a sort of at the end we arrived at sort of conical delta function. We had a compact form of this derivation for both spin polarization. ऐसे. So these are for one spin, two spin polarization. These are for positive energy states and negative energy states. इसका solution, Dirac solution. So इसको हमने represent it like this. Sort of normalization condition for them. So these are two solutions and it's sort of normalization condition for them. So now, if you see this way, so now what we are introducing these projection operators, which are acting on these states. Okay? Now these projection operators also have a property of these Lorentz invariants. It's also so अब ये है कि जो हमारे पास Dirac states के दो solutions हैं, positive and negative energy solutions. So we are going to see them through this our definitions of how we define polarization operators. Polarization case for spin up and spin down amplitudes. So if you do this exercise, so projection operators acting on this, let us see. So this we don't have Dirac solution. We have projection operators and this states. So इसका एक solution ये आएगा in terms of this. Or you can have projection operators acting on this will give us another solution. You can see. Now an operator is going to have both positive energy states and negative energy states. The way आपने जो quantum mechanics में किया था spin polarization, either up state or down states. Now we can see जो Dirac equation में हमारे पास दो solutions आ गए थे, positive energy states and negative energy states. इसको हमने दिखाया, we try to define them in terms of polarization states, and those polarization states may be spin up and spin down amplitudes in that sense. So we can say, so if we want to denote it, so lambda RP, we denote RP in terms of epsilon RP plus MC and lambda plus minus P is plus minus P plus MC twice MC in the covariant form. So we can denote them by this and this. So if you see this graph, we try to see energy states. So if you write them like this, for example, if you denote them, denote. So why you denote them by this way? We just suspend it for some time. And for direct calculation, by direct calculation we can get. So if you multiply this with this, so lambda RP, these are two states, two solutions, lambda RP into lambda plus minus 1. So we can multiply these two. So you have, if you multiply these two, it will be so इसमें थोड़ा सा just अपनी जगह आप कैलकुलेट करो. We multiply this and see whether it comes out to be this or not. So for a particular case, for example, we can verify. For example, lambda plus square p is equal to lambda plus जिसको आप कहते हैं ना प्रोजेक्शन ऑपरेटर की प्रॉपर्टी क्या है? Projection operator it will give g back. You come to the, if you operate it twice, it will come to back to its initial state. है ना? Spin state आप operate on operator again and it will come flip back to its original state. The same way we are taking the solutions, जो Dirac solutions के जो दो solutions हैं in terms of projection operators. And if you define things like this, so there are some identities. For example, if you multiply this lambda plus into this, it will come out to be lambda plus p and lambda minus p. So yes, it comes out to be 0. So you can verify it. The denominator में 2mc आएगा. This is p plus mc minus p minus mc. So it will cancel. So it will be 0. The other is lambda plus p plus lambda minus p is equal to 1. आएगा 1 to b. इसको आप 2mc आएगा यहाँ पे twice mc. So p plus mc plus MC. B minus P plus MC. B minus I. Plus MC. Minus P. Minus I plus M. 2 is equal to 1. Divided twice MC. 1 to 1. Or this is a simple way you can say it like this. And so here आप figure out as a homework you see whether it will come out with simple. So if we go for, we can have both polarizations, spin up polarization as well as spin down polarization. So for a spin up, we can take as sigma by sigma. Now, so we can rewrite, for example, two component non-relativistic spin projection operator. It's liberated by the explicit dependence on the z direction. इस तरह आप पोलराइजेशन करते हैं ना इलेक्ट्रोमैग्नेटिक वेव की, जैसे x में E फील्ड होगा, y में propagation will be along z direction. In the same way, you can have projection operator operating on different these solutions of positive energy solutions and negative energy solutions. So it will accordingly have two component non-relativistic spin projector in whichever direction it will have. So you can see the directions accordingly. Where z direction can be written as 1 plus as scale. So we can write. अब जो हमारे पास different identities थी ना हमारे पास, एक identity क्या थी? Gamma 0, gamma 1, gamma 2, gamma 3. इसको gamma 5 ऐसे था ना? और gamma 5 square का इसको minus 1, ठीक है? These can be gammas in terms of the spin projections. Sigma 0, sigma 1, gamma 0 is a 4 cross projections. But it's made of sigma 0. Sigma 0, 0, 0, 0. ये sigma 1, ये sigma 2 है, ये अब ये ऑपरेटर्स हैं, they are operating on these states, ठीक है? So अगर gamma ये है states, so these are different states, they act as operators, so they can flip depending upon identities क्या आ रही है, how we place the identities. उस हिसाब से they will take the value of these projection operators. For a case, for example, one plus sigma. So we can write it, for example, for a particular scalar for 4 vector can be written as 1 plus, this is, the book has written gamma 5, gamma 3, uz, gamma square s. We can see gamma 5, gamma 3 को multiply करके we can write it like this. So with the conventions, so we are interested in the covariance of the derivation. Now the covariance should also be in the spin projection operators the way we have defined. अगर covariance general form में हमने prove किया for derivation for observers in 2 reference fields which are covariance invariant. So that covariance should be also in the positive and negative energy solutions. That covariance should also be in the way we define projection operators, okay, which are operating on those solutions. So the covariance should continue in that sense. So covariant Dirac spin projection operator finally can be gamma 5 हम लेते हैं, we can take it 1 plus gamma 5 and 1 minus gamma 5, and gamma 5 is basically these all spin these gamma 0 operator, and gamma 5 square side 1 plus 1 क्या सकते हैं, minus 1 depends, for plus positive operation है, and that depends basically upon 1 plus minus. अगर plus operator होगा तो यहाँ plus होगा, और इधर it will be minus. ठीक है? So that will correspond to spin projection operators, positive as well as negative in that sense. So for example, in a rest field, So this is for positive operators. I will not write positive operators for negative energy spinners. So for negative, you can see the factor of minus C is here. Okay, positive 6. So I'm not taking positive energy operators. I will take the negative. Just be. Now further, what the book has done, so he has further redefined these operators in terms of, so if you want to relate further, एक हो गया general operators, then we have along spin projection operators. Then further we can, if we redefine the things, for which I have skipped, so if you want to write omega 1 momentum as this, omega 2 as, अभी है दो रेफरेंस फ्रेम है, just like in elastic collision, एक रेफरेंस फ्रेम है, it's moving away from the system or it is moving towards the system. So we can have, if it's moving away from the system, तो minus का फैक्टर आएगा. अगर ये towards the system आएगा तो minus and minus plus आएगा. So velocities normally add होती है ना. टू रिलेटिव वेलोसिटी है, एक बॉडी यहाँ से जा रही है, एक बॉडी या एक बॉडी ऐसे जा रही है, दूसरी बॉडी में, तो अगर इधर डिफरेंट डायरेक्शन आएगी इट विल ऐड, है ना. इस वाले केस में इट विल सबट्रैक्ट. So in the same way you can have these different projection states vis-a-vis their direction. The rest frame क्या है and moving frame क्या है, and accordingly these spin projections का factor, जो sign factor है ना, it will take or it will take up that sign factor accordingly. ठीक है. So this is the way the book he has further tried to modify these equations under these change of signs. You can see it. I will not write it. So in particular, if we want to summarize it operators, projection operators, the four projection operators, which will correspond to the four solutions. दो positive energy solutions आएंगे, दो negative energy solutions. जो कल मैंने कहा था ऐसे, 1 0 0 0 1 0 0 0. So we initially took only two solutions. Okay. In the yesterday's class, we took those positive energy solutions as well as negative energy solutions. In today's class, we also extended them to projective spin projection operators. Okay, with spin polarizations, and how the sign factor in terms of gammas. Okay, in that sense. So projection operators can be written as lambda plus b ये P2 ये लैम्डा पॉजिटिव एनर्जी सॉल्यूशंस है ना, ये P velocity 2 है, दूसरी P minus also includes the velocities also, relative velocities in the same frame opposite or, so we have also include अब इसकी जो negative energy solutions हैं it will be एक आएगा minus and दूसरा minus minus plus आएगा. Plus अब ये है कि जो प्रोजेक्शन ऑपरेटर्स, व्हाई डू वी इंट्रोड्यूस देम इन टर्म्स ऑफ प्रोजेक्शन ऑपरेटर्स. लेटर आप इस बुक में अगर आप जाओगे, देयर आर वेरियस ट्रेस थ्योरम्स, जो ऑल जो थ्योरम्स एट लीस्ट जो इस अपेंडिक्स है ना, अपेंडिक्स पार्ट ऑफ दिस यू शुड ट्राई how the properties of these gamma matrices. Okay, and then trace projection operators. So इन्हीं combinations को use करके they help us in calculating lot of things. It helps me and simplifying lot of things. So all the calculation techniques, algorithm can quantum field theory you normally or advanced quantum mechanics you calculate different scattering cross sections. So electron scattering, electron scattering, proton scattering. So these are all the things you have to calculate. अब इनकी spin polarization क्या है? Epsilon, mu, gamma. So that depends upon the projection operators, how they operate. That depends upon these plus minus factors. So ये जो हमने जो किया है, it will help us in calculating these diagrams or what I should say. So and if you know the spin component, you can avoid any unnecessary components in that sense.